Hi, we're working on looking at these graphs of two different equations. And even though every single time we graphed yesterday, there was a crossing point, today we're going to look at the fact that there's actually three different ways this can come down. And it might feel like I'm going a little fast, but I don't want to take too long to talk you through it. We're looking at three different examples. It can come out three different ways. And when we're done, we're going to play a game to practice these three ideas. And then when we work on it with algebra, it'll be in the back of your mind. You'll be thinking, okay, it could be one of those three things. And so we'll run into some funny stuff in algebra, and I wanted to prepare you by letting you see what it looks like as a graph. Here's our first example, and I've got two equations here. The first one, I'm just going to ask you a few questions so you can earn some points along the way. What is the slope of y equals 3x plus 2? Hopefully you said 3. How do you write 3 as a fraction? That's right, 3 over 1. All right, and then what would the y-intercept be? Yep, it would be 2. All right, and then we're going to graph that. So we're going to graph it at 2. And we're going to go up 3, 1, 2, 3, and over 1. Now in a perfect world, we'd go another point, but it goes off the graph. So one thing to keep in mind is that negative 3 over negative 1 is the same as 3 over 1, because a negative divided by a negative is a positive. That's right. So when we graph now, we're going to go down 3 and back 1. And that gives me 3 dots for connecting. So I'm going to connect those 3. And that'll be my first line. I haven't even looked at the other one yet. And we'll just make that red. Okay, so we have our first line. Our second line isn't written correctly. It's y plus 4 equals. And we don't normally graph y plus 4 equals. This is kind of a little on purpose kind of thing, add a little bit of level of excitement. So we're going to bring out the t-chart. How do you undo a plus 4? That's right, you subtract it. So I'm going to subtract 4. And can you combine 3x minus 4? The answer is no. When you combine 3x minus 4, you should still get 3x minus 4. All right, and then I'm going to ask you what's the slope of that? Yep, and as a fraction, 3 over 1. And then what's the y-intercept? Yep, negative 4. Make sure you say negative 4. Hopefully I didn't trick you. All right, you're going to start at negative 4, and then how are you going to graph a slope of 3 over 1? That's right, you're going to go up 3 over 1, up 3 over 1, and now you have your second line. And a lot of times when we're like in the moment, we may not realize that something wild and interesting is going on. So if you take a look now, when you're trying to find the solution of two or more graphs, two or more lines graphed, what are you looking for? That's right, you're looking for the spot where the lines cross. Okay, and so do these lines cross? And the answer is no, they don't. So when you're looking for solutions, you actually say there is no solution because the lines are, remember the word for the lines don't cross? That's right, it's parallel. So this is one of the ways it could turn out. It could turn out that there's no solution because the lines are parallel. All right, so that's item 1. I've got the second one here for you, and we're going to, again, answer some questions. What's the slope of y equals 2x plus 1? How do you write that as a fraction? Yep, hopefully you said the slope was 2 and it's 2 over 1. What's the y-intercept? Hopefully you said 1. All right, so we're going to graph that. Y-intercept at 1. How do you graph a slope of 2 over 1? That's right, you go up 2 over 1, and fortunately this one's playing nice, up 2 over 1. So I'm going to play connect the dots, give myself a green line. That's pretty wild. And then connect those together. All right, that's my first line. Now I'm going to go through and look at the next one. Oh snap, this equation is not ready for graphing. So I'm going to have to bring out the t-chart. And if a number is written up against a letter like this, 2 times y, how are you going to undo a times? That's right. You're going to divide it. So I'm going to divide by 2. And then I'm going to divide everything on this side by 2. So make sure everybody's included. And what is 2 divided by 2? That's right, it's 1. And we're pretty lazy, so we don't write 1y. We just write y. We're just happy to have it. What's 4x divided by 2? That's right, it's 2x. And what is 2 divided by 2? And that's 1. All right, so now I'm going to find my slope and my y-intercept. What's the slope of y equals 2x plus 1? Now, what is that written as a fraction? Yep, it's 2 over 1. And then what's the y-intercept? 1. So I go to graph it, and it has the same y-intercept as the last one, so I'm going to put a dot right there. And then it has a slope of 2. How do you graph a slope of 2? Up 2 over 1. Oh, snap. Why, it's the same line. Oh, didn't see that coming. Okay, I totally did. But I'm glad to show you that this is a situation. So sometimes when the equations are written differently, you might not catch it right away. But it turns out that they're actually the same line. So every dot on the first equation is the same as every dot on the second equation. So it turns out we have the same lines. So we have an infinite number of solutions. That means we don't just have one spot where it crosses and we don't have no spots where it crosses. We have an infinite number. So every answer on that line is correct. All right, so these are the 2 situations that are new. This third one, if we graphed this, we would get a nice graph out of this one. What's the slope of 5x plus 1? That's right, the slope is 5. And how do you write it as a fraction? 5 over 1. And what's the y-intercept? 1. All right. And then if we graph that, we go 1. And then we try to go up 5 over 1, but oh snap, it won't fit. So we're going to do negative 5 over negative 1, because a negative divided by a negative is, that's right, a positive. So we go down 5. 1, 2, 3, 4, 5, and we go back 1. All right, and then we play connect the dots again. And this is going to give us our equation. Or I'm sorry, our line. All right, that's your first one. All right, then the second one is kind of funky because there's no number in front of the x. What number's in front of the x if there's no number in front? That's right, it's a 1. So what would the slope be? If it was written as a fraction, 1 over 1. And then what would the y-intercept be? Yep, negative 3. All right, so we're going to start this guy at negative 3, and then we're going to go, that's right, up 1 over 1, up 1 over 1. This is everyone's favorite slope. All right, and we're going to play connect the dots with that. And this is going to give us our solution to our system. And if you notice, they're not parallel lines. They're not the same line. These are like the ones from the practice yesterday. This is the ones where they cross at one point. And what are the coordinates of that one point? Hopefully you said negative 1, negative 4. All right, so the moral of the story is that there's 3 ways this can turn out. It can turn out that you graph it and they're parallel lines and there's no solution. You can graph it and there's only one line after all that work. That means there's infinite solutions because they're really the same line. And then there can be the third item, which is what we were practicing yesterday and looking at yesterday, where they cross in one spot and you get one solution.